So you're in session 2R. This is the last of the IMS sessions of this virtual conference 2024, and this is to understanding how the SM0, SL1, SM1 SL0 and SM1 SL1 input message sent to IMS Connect works. So it's very much in depth on the workings of the messages for IMS Connect, and this has been led by Subhashish Sarkar, who is a BMC Software Senior Product Manager and owner for BMC, and he's been doing mainframe for well over 16 years. So if you've got any questions, then please do unmute yourself and ask that question. And without further, and just bear in mind that this session is recorded like they all are and will be available for playback. And obviously do feedback via the QR link at the end. So I'll hand it over to Subhash. Thank you.
Yeah. Thank you, Tom. Thanks a lot. Thanks a lot for the introduction. And so, as Tom said, final session for this wonderful conference, and I'm probably ending the IMS track with session on how the message on how the message protocols work in IMS Connect space, right? And as Tom mentioned, I'm working for BMC Software, and I'm working as a senior product manager or owner for the BMC AMI data for IMS portfolio products and solutions. If somebody wants to connect with me over LinkedIn or on X, formerly called Twitter, I've given the QR codes for both LinkedIn as well as X. So please feel free to connect with me if you wish to. Okay, and with that, I'll move to the technical aspects of this session. So starting off, let's try to understand some of the fundamental concepts and the basic terminologies first. So the IMS OTMA, or Open Transaction Manager Access client, communicates information to IMS and receives information from IMS in a prefix passed in front of the message or command. So among the information present in the prefix are commit mode and synchronization or sync level, right? So CM1 refers to commit mode 1, which is the send then commit mode. And CM0 stands for commit mode 0, which is the commit then send commit mode. So CM1 is send then commit, and CM0 is first commit then send. So, and similarly, moving on to the synchronization levels, SL0 refers to sync level or synchronization level 0, which means that the output message is not acknowledged by the OTMA client, right? And for sync level 1 or SL1, when the OTMA client gets the reply message from IMS, it has to send an acknowledgement or ACK message, ACK message, for the sync point to continue. However, the OTMA client should still not process the reply message until it receives something which is called the deallocate response message. So in short, for SL1, the OTMA client must send an ACK or ACK, which is a positive acknowledgement. It could also be a negative acknowledgement or NAK, NAK, for the output or reply message from IMS, right?
Okay, so can I just ask a quick question? So
yeah,
even at this stage, SL0 then, is that like saying async?
Yeah, sort of, yeah. It's because it's, you know, it receives the output message, but it does not ever have to acknowledge it back, right?
Okay.
Yeah, perfect. Yeah, that's right. Yeah. Yeah, and SL1 stands for, as I said, synchronization of sync level 1, right? And we saw that, for SL1, the OTMA client has to acknowledge, has to send an acknowledgement back. It could be a positive acknowledgement, which is an ACK or an ACK message, or it could also be a negative acknowledgement, right? Not all cases are success cases, right? There could be failures. So in case of a failure, it could be a negative acknowledgement or a NAK message, NAK message from the OTMA client. Okay, so having said that, the other entity that we are going to deal with is IMS Connect, obviously, right? So IMS Connect or icon, it's we call IMS Connect in short icon. IMS Connect. So I'll be using the terms interchangeably. IMS Connect and icon. So IMS Connect is an IBM provided OTMA client for TCP/IP. So IMS Connect is also referred to as icon. IMS Connect or icon is the TCP/IP gateway for IMS. So besides running the traditional IMS transactions on ZOS, an IMS programmer or DBA can now leverage applications running on the distributed side of the world. For example, maybe a Java web application, to be able to easily talk to IMS databases. Right. So the Java web application would go through IMS Connect to IMS as an OTMA or Open Transaction Manager Access transaction. Right. So IMS Connect to IMS as an OTMA transaction. So any transactions coming from the distributed side of the world, and wanting to talk to and wanting to interact with IMS would follow this route, right? Yeah. So in our case, the Java web application, which we are talking about, would go through IMS Connect to IMS as an OTMA transaction. Commit mode and synchronization of sync level are some protocols that OTMA clients have to stick to, right? So these protocols, any OTMA clients trying to communicate with IMS through IMS Connect have to stick to certain protocols, right? And the two important protocols for OTMA clients that they have to stick to are commit mode and synchronization level, right? And these information, as I've talked about, these information are passed in a prefix which is passed in front of the message or command. So IMS Connect or icon will send the output or reply message to the IMS Connect client and wait for the ACK or NAK message from the IMS Connect client, which is then sent to OTMA. Right? There is a timeout feature in OTMA while waiting for the ACK or the NAK message. Right. So the IMS Connect client will get another output or reply message after IMS Connect receives the deallocate message from OTMA. Right, unless in conversation. So we are not going to deal with the conversational type of processing here. I mean, that is a different world altogether. Just for the sake of simplicity, we are going to ignore the conversational type of conversations. I mean, conversational type of messages. Okay. So now that we have taken a good look at the terms, at the terminologies that we are going to use all throughout the session, terminologies like commit mode 1, commit mode 0, synchronization level 1, synchronization level 0, and obviously IMS Connect. Now let's get into the meat of the subject, right? So let us now discuss the CM0 SL1, CM1 SL0, and CM1 SL1 input message sent to IMS Connect works, right? And I'll just give you how I'm going to proceed through this webinar. I'm going to go through a series of diagrams, right, depicting each of the scenarios, right? And that this is going to be this is basically the flow that will be followed all throughout this webinar, right? So and if you see over here, each of these images have been have been numbered, right? So these numbers represent an important event, you know, for this particular message flow, right? And I'm going to explain all throughout this session. I'm going to explain for each of these images. I'm going to explain what the corresponding numbers mean, right? And that will basically explain the entire process flow. So number one, if you when I say number, you just refer to that particular section, and you know, I'll be explaining that particular section. So for number one, an IMS Connect client or an icon client sends an input message to IMS Connect. Right now, that input message could be a CM1 SL0 or CM1 SL1 or CM0 SL1 message. So moving on to number two, IMS Connect allocates or builds an SVT control block for the client. Right over here, this is number two. This and this, both number two. I'm explaining this now. So IMS Connect will allocate or build an SVT control block for the client if it does not already exist, and will send the input message to IMS OTMA via XCF, the cross-system coupling facility. Now, for CM1, the transaction pipe or T-pipe name would be the port number that received the input message. But for CM0, the transaction pipe or the T-pipe name would be the client ID, right? So this is an important point to remember. For the CM1 protocol, the T-pipe name is usually the port number that received the input message. And for the CM0 protocol, the T-pipe name is usually the client ID. Okay. So moving on to the third point, number three over here, OTMA processes the input message. A control block called a transaction instance block or TIB is allocated. RACF or any other system authorization facility, a SAF product is called if needed. You know, it could be CA, CF2, CA top secret, or RACF, right? Whatever the mainframe shop uses. The input message is first inserted. The input message will first be inserted into the IMS message queue over here, and then enqueued on the transaction queue. Right. So this is all about number three. Now for CM0, after the input message has been enqueued on the transaction queue, OTMA will free the TIB control block. This is specifically for CM0. After the input message has been enqueued on the transaction queue, the OTMA goes ahead and frees the TIB control block. Not for CM1. We'll see how that behaves for CM1. Now moving on to number four over here. This is number four. The IMS transaction application program will now do a get unique or GU to the input output program communications block IOPCB to retrieve the input message. Right. The input message will then be processed by the IMS transaction application program as per the existing logic. Moving on to number five, which is this. The IMS transaction application program will then do an insert or ISRT of the reply message to the IOPCB. Right. Moving on to number six, which is over here, right? On the OTMA land. In case of CM1, the reply message is anchored on the TIB, right? And in case of CM0, the reply message is enqueued on a temporary queue. Remember, in number three, we said, so in number three, we said that, right, for CM0, after the input message was enqueued on the transaction queue, the OTMA actually went ahead and freed the TIB control block. So when I'm explaining number six, in case of CM1, the reply message is anchored on the TIB. But in case of CM0, since the TIB control block was already freed, the reply message is enqueued on a temporary queue.
Is it possible just to go back to the previous slide with those definitions in and then flip back again, just for other people's benefit, maybe in the future? Because I know you've given those. Yeah. So it is CM0 is the commit mode 0, and
Yeah.
that's commit then send, and then the
Commit then send.
CM1 is send then commit.
Right.
Okay.
Right.
Yeah, that's fine. Brilliant.
Yeah.
I
Okay.
just thought it might benefit if people refer back again just once.
Yeah, absolutely. I myself sometimes also tend to get confused sometimes. So, you know, yeah, it's always good to flip back. Okay, and now on this slide, finally coming to point number 7 again on the MPL land. The IMS application program will now, at this point, the IMS application program reaches a sync point, because it has done a GU IOPCB and then an insert to IOPCB, right? So naturally, the IMS application program reaches a sync point, right? Now, since this is going to be a huge, if I am to, how will I say, if I am to draw the diagram one after the other, it's going to be a huge diagram, right? So what I've done is, on each of the slides, I've marked a logical breakpoint, right? And then on the next slide, we will start from that logical breakpoint, right? So for example, over here on this slide, number 7, when the IMS application program has reached a sync point, let's consider number 7 to be a logical breakpoint, right? Let's say logical breakpoint 1. So now, let's continue on with our journey from logical breakpoint 1, right? So again, here moving on to numbering system 8A, IMS OTMA will now retrieve the reply message from the message queue. If I go back, if I go back over here, point number 5, right? The application, the IMS transaction application program had done an insert of the reply message to the IOPCB, right? So over here, IMS OTMA will retrieve the reply message from the message queue, right? Which is point number 8A. So it gets the reply message. Now moving to 9A, over here, IMS OTMA will now send the reply message to IMS Connect via XCF and deletes it from the IMS message queue over here, right? Just follow the numbering system. And then moving on to 10A, IMS Connect will anchor the reply message on the SVT. Remember, on the first slide, there was an SVT control block that was created. IMS Connect, on IMS Connect point number 2, there was an SVT control block that was created. So over here, now, IMS Connect will anchor the reply message on the SVT and waits for the deallocate or deallocation message from OTMA, right? And remember that for CM1 SL0, even though the OTMA client, which is IMS Connect in our case, receives the message before the sync point is complete, right? It should not process the message until it receives a deallocation message or deallocate confirm message from OTMA, indicating the status of the sync point, right? So in 11A, moving on over here, 11A, sync point proceeds. OTMA starts processing the sync point. So phase 1 and phase 2 sync points begin. Now over here, let's consider 11A to be another logical breakpoint. Let's call it logical breakpoint 2, right? Now from over here, if you think about it, from 2 options can actually branch out from logical breakpoint 2. One is, so logic 11A is logical breakpoint, right? And what happened in logical breakpoint? The sync point proceeded. So OTMS started processing the sync point, right? So that happened in logical breakpoint 11A. So if you think about it, 2 options can actually branch out from logical breakpoint 2, which is 11A. One is the sync point can either complete successfully or there could be a sync point failure. There are two situations that can actually branch out from logical breakpoint 2. And we'll take a look at each of these scenarios in the subsequent slides. Right, and remember, over here we are taking a look at the CM1 SL0 input message right now. So if you just go back, CM1 is send then commit, and then SL0 is sync level 0, right? So SL0 means that it's not needed by the OTMA client to acknowledge the output message from IMSA, right? So the OTMA client does not need to send an ACK or an ACK message, right? So this is the case that we are talking about over here. So we are taking a look at the CM1 SL0 input message flow right now. Now we are at logical breakpoint 2, and as I said, the two options can branch out from logical breakpoint 2: the sync point completing successfully or sync point failure. So let's move ahead. We will now branch out over here. If you see, we'll now branch out from logical breakpoint 2 and take the route of the sync point completing successfully. Let's consider first the case of the sync point completing successfully. Right. So moving on to 12AA, sync point processing completes successfully. Phase 1 sync point ends. Moving on to 13AA, OTMA sends the deallocate confirm message. Since the sync point processing completed successfully, what OTMA does is OTMA sends the deallocate confirm message to IMS connect, right? Over here, if you can see, OTMA is sending the deallocate confirm message to IMS connect, right? But again, this will not happen if it is in conversation, and I said that we are not going to take a look at the complex case of conversational type of processing here, right? So now moving on to 14AA over here, OTMA will delete the TIB control block, but again, not if conversation, and freeze the input message, right? OTMA frees the disk relative record number, or DRRN, of the message. DRRN is the actual address of the message within the IMS message queue, right? So when I say that OTMA frees the input message, it basically goes ahead and frees the DRRN of the message, right? So moving on to 15AA over here, on the MPR side, sync point completes, the phase 2 sync point ends. Moving on to 16AA, IMS Connect sends the reply message to the IMS Connect client, right? And in 17AA over here, if a persistent socket is in use, IMS Connect will keep the connection open and will not free the SVT control block. Otherwise, the SVT control block is freed, right? So remember on the first slide, I said that, SVT control block is created if it does not already exist. Now you will probably understand why I had said if it does not already exist, right? So if it is a persistent socket, if a persistent socket is in use, then IMS Connect will keep the connection open and it will not free the SVT control block. So the SVT control block will already exist for the next message or the next transaction, right? Otherwise, if a persistent socket is not in use, so in other words, if a persistent socket is not used, then the SVT control block is freed, and then for the next case, the SVT control block has to be reallocated, right? And then moving on to 18AA, the IMS Connect client will process the reply message. So this completes the case of what happens when an IMS Connect client sends a CM1 SL0 input message to IMS Connect and the sync point completes successfully. So we just looked at the case of a CM1 SL0 input message and the sync point completing successfully, right? Now remember, from logical breakpoint 2, we had 2 branches, right? So we have taken a look at the sync point completing successfully branch, right? Now we will take a look at the other branch, which is the sync point failure, right? And the message is still CM1 SL0, right? So now, again, over here, if you see, we will branch out again from logical breakpoint 2, but this time we will take the route of sync point failure, right? Now 12AB, if I come to 12AB, phase 1 sync point processing fails on the OTMA side of the house, right? And then under 13AB, so what happens is, since phase 1 sync point processing has failed, OTMA will process the sync point failure and it sends 2 messages, DFS XXX and deallocate abort message, right? So remember, in the previous case, in the case of the success, it was a deallocate confirm message, right? But in case of a failure, 2 messages will be sent by OTMA. One is DFS XXX message and the other one is a deallocate abort message. So OTMA sends these 2 messages to IMS Connect via XCF, right? Over here you can see OTMA sends these 2 messages to IMS Connect via XCF. The messages can arrive in IMS Connect via XCF in any order, right? Moving on to 14AB, again on the OTMA land, OTMA will delete the TIB control block. Moving on to 15AB on the Ampere land, phase 2 sync point will also fail since the phase 1 sync point failed. So phase 2 sync point fail on the Ampere side, and the application program on the Ampere side will now abend, right? Now moving on to 16AB, over here, IMS Connect will now process the sync point failure and it will discard the reply message, right? I mean, since there has been a failure, sync point failure, IMS Connect will discard the reply message. IMS Connect will also send the DFS XXX message to the IMS Connect client, right? Now, 17AB over here, if a persistent socket is in use, again, the same thing, IMS Connect keeps the connection open and does not free the SVT control block. Otherwise, the SVT control block is freed, right? Moving on to 18AB over here, the IMS Connect client will now process the DFS XXX message, right? So this is now this image is a pictorial representation of what happens when an IMS Connect client sends a CM1 SL0 input message to IMS Connect, but this time a sync point failure occurs. So we have taken a look at both the cases, right? CM1 SL0 input message, but we have taken at both the cases of a sync point completing successfully and a sync point failure. Okay. Now, remember, now we'll again go back to logical breakpoint 1. So remember, I'll just flip between the sites, right? Because it's very difficult to remember what logical breakpoint 1 was. So logical breakpoint 1 was the first slide, or in fact, the second slide, right? So we had taken a logical breakpoint 1 at this, at number 7, at MPR, right? When the sync point had just started, right? So we now again go back to logical breakpoint 1. Over not here, right? This one, yeah, logical breakpoint 1. Why do we again go back to logical breakpoint 1? Because now we are going to consider CM1 SL1 protocol. Remember, we have completed CM1 SL0 protocol, but now we are going to take a look at CM1 SL1 protocol. And so we go back to logical breakpoint 1, which is the common point, right? For all the protocols till logical breakpoint 1, all the steps happen. These are the list of all the common steps, right? So from number 1 to number 7, whatever be the protocol, number 1 to number 7, these are the list of common steps for each protocol. Now, from logical breakpoint 1, we will we'll consider specific cases. So here we consider the case of CM1 SL1. So we'll go back to logical breakpoint 1 over here once again and continue on with our journey from there. Now moving on to 8B over here, IMS OTMA retrieves the reply message from the message queue, right? And then 9B over here, IMS OTMA, after it retrieves the reply message from the message queue, IMS OTMA will send the reply message to IMS Connect via XCF. IMS OTMA then waits for an ACK-NAC. Right? Remember, now we are considering SL1. Right? So SL1 is that OTMA client has to send either an ACK or an NAC. Right? So after IMS Connect, after IMS OTMA sends the reply message to IMS Connect via XCF, IMS OTMA has to wait for an ACK or a NAC message. Sync point processing, database locks, and external subsystem DB2MQ, etc. locks are held at this point, and the message processing region or MPR remains occupied. Right? Why? Because OTMA is waiting for an ACK or a NAC message. Right? And then at 10B over here, IMS Connect will anchor the reply message on the SVT control block. Over here. Moving on to 11B over here, IMS Connect sends the reply message to the IMS Connect client and waits for the ACK or NAC. Right? Now over here, 11B, let us consider 11B to be another logical breakpoint. Let's say logical breakpoint 3, right? Now, again over here for logical breakpoint 3, two options can actually branch out from logical breakpoint 3. The IMS Connect client can either send an ACK or a NAC, right? I mean, what is logical breakpoint 3? Logical breakpoint 3 is IMS Connect has sent the reply message to the IMS Connect client, and now IMS Connect is waiting for either an ACK message or a NAC message from IMS Connect client. So this is our logical breakpoint 3, 11B, right? Now, two options can branch out from logical breakpoint 3, right? Now, the IMS Connect client can either send to IMS Connect either an ACK message or a NAC message, right? So these are the two branching, the branch code, branch. These are the two routes that can go out from logical breakpoint 3. So now we will branch out from logical breakpoint 3 and consider the case when the IMS Connect client, when the IMS Connect client sends an ACK. So we consider the first case of the IMS Connect client sending IMS Connect an ACK reply message. Okay. So 12BA over here, 12BA. The IMS Connect client gets the reply message and sends an ACK, right? The IMS Connect client gets the reply message from IMS Connect and it sends an ACK message back to IMS Connect. Now 13BA, the IMS Connect client will hold the reply message. Over here, you see 13BA, the IMS Connect client will hold the reply message and wait for the deallocate message to see if the sync point completed successfully. Remember the deallocate confirm and deallocate abort message. So now the IMS Connect client is waiting for whether it receives a deallocate confirm message or a deallocate abort message. Just to check if the sync point completed successfully or if there was a sync point failure, right? So 14BA, IMS Connect sends the ACK to OTMA, right? And 15BA, sync point proceeds, OTMA starts processing the sync point. Phase 1 and phase 2 sync points begin. Now again, 15BA, we'll consider 15BA to be another logical breakpoint, logical breakpoint 4. Again, as you can probably guess, two options can branch out from logical breakpoint 4. One is sync point completing successfully and sync point failure, right? So again, this message, this figure we are considering CM1 SL1 input message, and we are considering the case when the IMS Connect client sends an ACK to IMS Connect. All right, so logical breakpoint 4, again, we will now branch out from logical breakpoint 4 and take the route of the sync point completing successfully. Right, so 16BA, this will probably now sound familiar to you. This is the case of sync point completing successfully. Right, so 16BA, phase 1 sync point completes successfully. 17BA, over here, OTMA will send the deallocate confirm message to IMS Connect. 18BA, over here, OTMA will delete the TIB control block. 19BA on the MPL land. Phase 2 sync point will also complete successfully. And then on over here, 20BA, 20BA, this number 20, IMS Connect will send the deallocate confirm message to the IMS Connect client, right? And 21, again, if a persistent socket is in use, IMS Connect will keep the connection open and will not free the SVT control block, or otherwise the SVT control block will be freed, right? So that is number 21. Now 22, the IMS Connect client will process the reply message, right? Because the sync point has completed successfully, right? So this is the pictorial representation of what happens when an IMS Connect client sends a CM1 SL1 ACK input message, right? This is the protocol of CM1 SL1 ACK input message sent to IMS Connect, and the sync point completes successfully. Now remember, again from logical breakpoint, right? We'll now again branch out from logical breakpoint 4 and take the route of sync point failure, right? Again, this should sound familiar, right? 16, point number 16, phase 1 sync point will fail now. Point number 17, OTMA will process the failed sync point. OTMA will again send 2 messages. Remember, DFS XXX and deallocate abort message to IMS Connect via XCF. Now the messages can arrive in IMS Connect via XCF in any order. Point number 18, over here, OTMA will delete the TIB control block. On the point number 19, on the Ampere side of the house, phase 2 sync point will also fail and the application program will abandon. Point number 20, over here, IMS Connect will process the sync point failure and will send the DFS XXX message to the IMS Connect client, right? And again, 21 is very similar. If a persistent socket is in use, IMS Connect will keep the connection open and will not free the SVT control block. Otherwise, the SVT control block gets freed. And point number 22 will be the IMS Connect client will process the failed sync point and will discard the reply message. The IMS Connect client will also process the DFS XXX message, right? So with this, we have taken a look at what happens when an IMS Connect client sends a CM1 SL1 ACK input message to IMS Connect, but a sync point failure occurs. Right, now we'll go back to logical breakpoint 3. Remember over here, logical breakpoint 3, and I had said that, right, for logical breakpoint 3, 2 situations were possible, right? IMS Connect client either sends an ACK message or a NACK message. So for the next 2 slides, we just considered the ACK message scenario. So CM1 SL1 ACK, sync point completing successfully. CM1 SL1 ACK, sync point failure occurs. And now we again go back to logical breakpoint 3 and we'll now consider CM1 SL1 NACK. Right? So we go back to logical breakpoint 3 and continue on with our journey from there. We'll now take a look at the case when the IMS Connect client sends a NACK message to IMS Connect. Right? That's the situation. That's the scenario we are taking a look at right now. Okay, just taking a look at how am I doing with time. Yeah, I think it's good. Okay, so taking a look at point number 12, The IMS Connect client gets the reply message. The IMS Connect client gets the reply message and sends a negative acknowledgement or NAK. Right? Now, taking a look at 13, the IMS Connect client discards the reply message and waits for the deallocate message. Right? Number 14 over here, 13. Yeah, 13 and why is 14? Number 14 should be, yeah, over here, right? IMS Connect sends the NAK to OTMA. Number 15, sync point proceeds. OTMA starts processing the sync point. Phase 1 and phase 2 sync points begin, right? Number 15. Number 16, phase 1 sync point fails. Number 17, over here, OTMA processes the failed sync point and sends the DFS XXX message and deallocate abort message to IMS Connect via XCF. The messages can arrive in IMS Connect via XCF in any order. Number 18, over here, this process should sound familiar. OTMA will delete the TIB control block. And then moving on to the MPL LAN, 19, phase 2 sync point will also fail and the application program will abandon. Moving on to 20, IMS Connect will process the sync point failure. Over here, number 20, IMS Connect will process the sync point failure and sends the DFS XXX message to the IMS Connect client. Again, on 21, for point number 21, if a persistent socket is in use, IMS Connect will keep the connection open and will not free the SVT control block. Otherwise, the SVT control block will be freed, right? And finally, point number 22, the IMS Connect client will process the DFS XXX message. Now, with this, we have taken a look at what happens when an IMS Connect client sends a CM1 SL1 input message to IMS Connect, and the IMS Connect client sends a NAK. So we have probably completed the entire CM1 SL1 message protocol scenario, right? So we have considered, so let's think about what we have covered. CM1 SL1 ACK, CM1 SL1 ACK sync point completing successfully, CM1 SL1 ACK sync point failure, and then CM1 SL1 NAK sync point failure, right? Okay. Now again, we move to logical breakpoint 1. Again, if I just go back to slide number 3, this is our logical breakpoint 1. So we'll again start our journey from logical breakpoint 1, right? And why? That's because we have completed all the CM1 cases. Now we will take a look at the CM0 cases. That's why we move back to logical breakpoint 1 once again. Now let's move back to that slide. Yeah, I think this is the slide, right? Yeah, this should be the slide. Okay, so we go back to logical breakpoint 1 once more and continue on with our journey from there by taking a look at the CM0 protocol. So we are almost at the end. We have completed CM1 protocol and now we are at CM0 protocol. Right. So point number 8, sync point proceeds. 9, OTMA will enqueue the reply message on, for CM0, OTMA will enqueue the reply message on a queue anchor block, which is called a QAB. It's called a queue anchor block, right? Number 10, sync point is successful. 11, on the MPS side, sync point completes. Number 12, IMS OTMA does an internal GU to retrieve the reply message from the IMS message queue, right? So number 12, if you see over here, IMS OTMA is actually doing an internal GU to retrieve the reply message from the IMS message queue. Moving on to 13, IMS OTMA will then send the reply message to IMS Connect via XCF. 14, IMS Connect will anchor the reply message on the SVT control block. Moving on to number 15, IMS Connect will send the reply message to the IMS Connect client and will wait for the ACK or NACK reply from the client. Right now with 15C, let us consider 15C to be another logical breakpoints, and this time it will be logical breakpoint 5, right? Because previously we had coded till logical breakpoint 4, so this logical breakpoint will be logical breakpoint 5. Now again, right, two options can branch out from logical breakpoint 5. The IMS Connect client can send either an ACK or a NACK reply message back to IMS Connect. Right, and remember, we are taking a look at the CM0 SL1 input message, right? So as you can, so SL1 means the IMS Connect client has to either send an ACK or a NACK, right? And we are now taking a look at CM0 protocol, right? So at logical breakpoint 5, which is 15C, two routes can be, two routes are present. The IMS Connect client can either send an ACK or a NACK reply message back to IMS Connect. Right, so we will now branch out from logical breakpoint 5 and consider the case when the IMS Connect client sends an ACK reply message back to IMS Connect, right? This should again sound very familiar, right? So point number 16 over here, the IMS Connect client gets the reply message from the IMS Connect and sends an ACK reply message back to IMS Connect. Moving on to 17, the IMS client can then go ahead and process the reply message. Number 18 over here, IMS Connect sends the ACK reply message to OTMA via XCF, right? And number 19 over here, OTMA can then safely go ahead and dequeue the reply message, right? So with this, we have taken a look at what happens when an IMS Connect client sends a CM0, remember, CM0 SL1 ACK input message to IMS Connect, and the sync point completes successfully. Moving on, again, logical breakpoint 5. We'll again branch out from logical breakpoint 5, and this time we'll consider the case when the IMS Connect client sends a NACK reply message back to IMS Connect, right? So 16, the IMS Connect client gets the reply message from IMS Connect and sends a NACK reply message back to IMS Connect, right? Over here, 16. 17, the IMS Connect client notifies the user. Number 18, the IMS Connect will now send the NACK message to OTMA. And 19, OTMA will requeue or purge or reroute the reply message, right? Because it's a NACK, it will try to requeue or purge or read out the reply message. Right. So with this, we have taken a look at what happens when an IMS Connect client sends again CM0 SL1 input message to IMS Connect and a client negative acknowledgement or NACK occurs. Right. So we have taken a look at all the cases, right? Till this point. So if you look at it, IMS Connect actually sends the output or reply message to the IMS Connect client and actually waits for the ACK or NACK from the IMS Connect client, right? So once IMS Connect receives the ACK or NACK from the IMS Connect client, it sends the ACK or NACK to OTMA. Now there is a timeout feature in OTMA. I'd probably discussed this, but I'm discussing this once more. There is a timeout feature in OTMA while waiting for that ACK or NACK message. The IMS Connect client will receive another output or reply message after IMS Connect receives the deallocate message from OTMA. Remember that deallocate confirm or the deallocate abort message, depending on whether the sync point completed successfully or it was a sync point failure. But remember, all this happens for non-conversational type of processing. We are not discussing the conversational type of processing here, which is extremely complex, and we want to avoid that complexity. Okay, I think the final topic of discussion will be this case, and this is a typical case, not a very frequent case, but this can definitely happen. And it happens, obviously, right? So this case is, so this is our final topic of discussion for today's session, and it involves understanding what exactly happens when an IMS Connect client sends an input message to IMS Connect and the input message is nagged by OTMA itself, right? So again, for A, an IMS Connect client sends an input message to IMS Connect. B, IMS Connect will allocate an SVT control block for the client if it doesn't already exist, and will send the input message to IMS OTMA via cross-system coupling facility or XCF, right? So this is all standard, right? And now moving on to C, over here, OTMA will process the input message, but in this case, one or more errors occur in OTMA while it tries to process the input message, right? Now, an error could be, things like invalid transaction code or stopped transaction or security failure, maybe an expired message, TIB or TPI flood, to name a few, right? So now moving on to D, OTMA will NAC the input message with a sense code. It's TMAM CSNC in the OTMA header. That sense code field is called TMAM CSNC in the OTMA header, and also a reason code, right? That is TMAM CRSC in the OTMA header, right? So OTMA will NAC the input message with a sense code and a reason code. Now moving to E, over here, OTMA will send the NAC message to IMS Connect via XCF. Moving on to F, OTMA will delete the transaction instance block or TIB control block if it was allocated. Moving on to G, IMS Connect sends an error message to the IMS Connect client, right? So if IMS Connect sample user message exits are used, then REQ STS error message is sent, right? And moving on to H, again, if a persistent socket is in use, IMS Connect keeps the connection open and does not free the SVT control block. Otherwise, the SVT control block is freed. And finally, I, the IMS Connect client will process the error message, right? It will process the error message. So I think that is all about the the message protocols that are involved in OTMA and IMS Connect message flow structure. So I think, yeah, I've covered all the points, and I think I'm within time this time. So but I'm done with my session. So if there are any questions, I'm happy to take them, right? And this is the QR code for the review or feedback of the session.
Well, thanks very much, Subhadash. That was you did well to explain all of that, because it was quite complicated in places with the flows, and I thought you did really very well. So much appreciated. I've got a couple of questions. I didn't want to interrupt your flow on some of what you were talking about, but it's
Sure.
a couple of actual questions on top of what you've said for the different scenarios we've got here. So am I right in thinking that IMS Connect, whichever type you go for in your solution for what your requirements are, am I right in thinking that you can't actually do a message switch to another transaction and then reply back to to IMS Connect? So are we saying that, because I know sometimes our applications, for example, we do transaction one, so it might come in via IMS Connect, and I'm not saying which of the it is important in terms of which type of setup we have for the IMS Connect here, but broadly speaking, we've got some transactions that would actually, you'd do one transaction, and then you'd then message switch and then to another transaction and then you'd want to reply back. So is that actually able to be done for any of the scenarios that you're talking about, all the scenarios that you're talking about? Will it cater for that or not? So do any of the scenarios actually cater for that in IMS Connect?
I think I think we can do that, Tom. If I remember, because I was trying to think about, you know,
Mm,
we have a product called, BMC AMI Energizer for IMS connector, right? And there is on the ISPF panels for that product, there is a test transaction panel, that we host on the product, and I think we can do conversational processing, but it's quite complicated.
yes,
Honestly speaking,
yeah,
I
you
haven't
did
really tried
mention
it
that.
out.
Yeah,
Yeah.
but what I was thinking was because it's not necessarily for this one. It's actually you've got transaction one, which is going to be it's going to come in from IMS Connect,
Right.
and then and I'm not saying about which options we're talking about here. I'm just saying ignorantly, it comes in via IMS Connect, and then or well, if you look at it from another point of view, if you do it via MQ, for example, MQ coming in, you can actually do a message switch to another track, so you can read it off the queue, go via MQ into O2May, then into your program, schedule your program, and do your program process and get unit and all that kind of stuff. And then what you can do is you can then say, right, so I'm going to create another message, say an O3 message, and then I'll put that as an input to another transaction. And that then that O3 output becomes an O3 input message
Yeah.
to another transaction, which will be another application, running another application, because basically we've got quite a lot of those where we actually do one transaction and it does something, one program, then it message switches to another transaction and then does something else. And then it then can then reply back in MQ terms. As long as you've got the details correctly, you can reply back from the IOPCB, or you do an AIB call, say, to get the term L term. And then in theory, you can actually respond back as if it was the first transaction, as if it was responding to the first transaction on the list coming in.
Yeah.
So,
Yeah.
all I was wondering was, can you actually do? And it is sort of it's not my terminology for conversational would be reply to the same one in the beginning, yes, but not
Right.
necessarily with that message switch. And I'm saying something slightly different where it would actually, can we actually cater for a message switch to another? And I think we've asked IBM that, and I thought they said they hadn't got a way of doing that. So conversational processing might be able to be done, but that's not quite the same thing as doing a message switch from one transaction to another and then replying back to the same. I mean, it might actually, it
I,
might be, it's a bit like conversational, but not quite.
Right, and I think, you were right in the sense that, the message switching, when IMS Connect
Because
is
it's like
involved.
a unit of work. So like in the unit of work, it goes to unit of work two, basically, because of course it's treating that as a completely different transaction, but it's trying
Right.
to build those headers for going back, in this case, to MQ, or in the case of, a question mark, whether or not Connect can actually do that. I guess that's one for IBM more than anything, isn't it? It's not one
I
for us.
I think so. Yeah. Honestly speaking, at this point, I have to take a vague guess at it, because uh, uh, it's not a question. I mean, I'm very comfortable with in terms of
Yes,
conversational processing. Because I've hardly ever played with it, right? So
yes,
I would have to take a wild guess, but if I remember
mm,
the screens that are present in Energizer,
yeah,
I think we definitely I mean, when we say we, I mean, when I think I saw an option for conversational processing. So I think we support it to a level, but then you were
Yeah.
talking about that message switch structure, right? That you were referring to. I
Yeah, I
am
mean that's a
not
little
really
bit like,
sure. Yeah,
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 yeah. I think that's slightly different. The message
right.
switch is not necessarily a conversation. It's just
Exactly.
replying
Yeah,
back to the same client, but with a different unit of work. So unit
yeah,
of work two, if you like,
yeah,
and
yeah.
building the message back. But I was just wondering when you were talking about the different options, whether or not it could. And I think it's one for IBM that. So that's not, that's fine. I'll try and get the reply from them anyway, but it's not going to be in this presentation. And then the other thing I was thinking about, just not when we do, you've talked about where we do the phase one and phase two commit
Mm-hmm, mm-hmm,
within all of these scenarios. And
mm-hmm.
um, I guess, if you've got an IMS database that you're trying to do a sync one,
Mm-hmm.
sync two in a data sharing, then you've got the uh, when you've got also DB2 involved, you've got
Right.
IRLM who's the lock master, if you like, and then you have to sync your it's a two-phase commit, but but
Yeah,
but
yeah.
you will also have to go to DB, if you've got a DB2 update as well as an IMS one, then you have to do that. The IRLM going to IMS, it has to go to the DB2 subsystem and then get that reply. And then once everybody's fine, then it will then do the commit in the second phase. But
Exactly.
that
Yeah.
but that's, I guess, over and above what you've talked about in terms of the actual IMS Connect, different ways of doing the communication and the send and receive and everything. So I was just trying to get my head around that a little bit. But I guess the points there are that DB2 thing will be a subset of some of this.
I
Um,
I I think so, Tom. And I think what you said is probably how it should work, right? I mean, that phase two commit should be considered successful only after that two-phase commit with DB2 is also considered successful, right?
right,
So
yeah. Okay.
yeah,
So for example, when you're saying about sync OK there for that
yeah,
OTMA, sync OK, the 10C, we're saying, and then it says, get, I'm trying to get around it. You were saying that, yes, you mentioned two-phase commit
yeah.
in the processing, and then I guess we've just got to say that in that second phase, wherever that is on the diagram, maybe you can just circle it, not necessarily here, but wherever that is, it would also include the DB2 going to the DB2 partner and then doing the check. And it's not because you've said it wrong here. It's just adding the DB2 bit to it in the diagram. That's all.
Yeah. I think I haven't thought about that, but yeah, I think I think
But
exactly. I
that's
mean, so
fine. But I'm not saying
right.
it's not. I'm not saying it isn't. I'm just thinking, where, because it's like, you've got the different log messages, you've got the different IMS.
Right.
Um,
And that would be here, right?
yes,
Right, Tom, over here,
yes,
10C, right?
yeah.
Because unless that two-phase commit with DB2 is successful, then I cannot come and say that, my phase two sync point is okay. So that has to be that coordination has to be done in order for me to be able to say that, this sync point is okay.
Okay, I see. So
Yeah.
right, I see. So you're yeah, but when you mentioned two-phase commit in some of your presentation, then you did
Oh,
say about two-phase commit, but did you
oh,
mean
no, no, no,
not
no. I
that
so
bit of the two-phase commit? You're
no, no, no.
talking
So
about
so
the connect two-phase commit,
yeah. So
not that.
this is
So
not that.
yes, yes, and that's where I was also getting confused. I was thinking, hang on a minute, you're not talking about two-phase as in.
Oh, no, no. So okay. So
So,
no,
so
that is a
this is a
different.
two-phase. Yeah, it's within the two-phase. Yeah, sorry, within the IMS Connect
Uh, uh,
two-phase
uh,
commit. A
uh,
subset before
s-
that will have been the two-phase commit with the IMS and the DB2, is what we're saying.
yeah, yeah. So when
Does that
I'm
make
when
sense?
Yeah, made sense because
Yeah.
because that's exactly what I meant. So when I said in during all throughout my presentation,
Yes.
when I use those
Yes.
terms phase one and phase two, so what I meant by phase one was the
Yeah.
OTMA code
Yes.
doing its own commit,
Yeah.
and then also the the message processing in the application
Yeah.
program in the message processing region also completing
Right.
its own
So
own commit.
yeah. So basically, what we're saying is the DB2 phase commit will be phase two, phase one's phase two will be within the sync,
Within that sync
10C.
point.
Yeah, yeah, and that will be completed before we do the second phase of the connect.
Yeah, phase two of the of my
Yes, yes,
connect
Mike and I
yeah.
can. Yes, yes,
Yeah,
right. I
yeah,
get that now, and that's.
exactly.
I was just trying to make it. Also, I don't
Yeah.
know. And then the final point I was going to make. So that's great. That really enhanced it for me. And then the third thing was, um, have you got like? I mean, you've got use cases for all of these about what is the best thing to do. So I'm presuming, if you're doing simple but without doing updates, and I know there's no real right or wrong answer to this, but presumably certain types of applications will favor each of these types of modes with the commit mode and the synchronization. Some of them will be that you are wanting to be async, and some of them will want to have not async and send
Yeah.
then commit and commit then send. So is there some major advantages and disadvantages of either? And there must be, but it would be nice to have those detail bulleted somewhere. And I'm not saying in this presentation, but that's probably for another topic, maybe.
Well, no, what I've
Because
heard
that's the
is
technicals, isn't it? This is the technicals. Whereas,
mm,
whereas it'd be nice to know the advantages and disadvantages from an application
of each.
perspective for each. But
Yeah,
but you can
perfect.
kind of work it through with what you've just said. That's all.
Right. Yeah, that's a good point, Tom. I'll add that. And it's an interesting thing because I presented a part of this last year,
I know
and
you
one
did. And,
yeah,
and you
and
did you split it up, didn't you, into different
I
sessions? And we've
had actually
actually put it
split it
all
up.
into one session. So it's actually a big
Right.
technical session, this one.
Yeah, I thought that this was probably going to be more effective because those
Yes.
sessions, if somebody attends one of them and probably does
Yeah,
misses the other,
I agree.
then
Yeah.
they would not understand. Then they would probably miss the whole entire
Yeah.
thing, right? Over
Yeah. And you
here,
keep on having to refer back a little bit. And actually, it's useful to have it all in one. I agree totally. Yeah.
yeah,
Yeah.
yeah.
But
So
maybe that's a topic for something else, like the advantages and disadvantages of either. But that's
right.
that's
No,
that's
I
silly.
think I think that would be a good addition. Maybe at the end, maybe
Okay.
one or two slides. I'll
Okay.
definitely.
Okay.
That's a great point, Tom. I'll
Okay.
have to do that addition. Yeah.
Right, no worries. Anyway, thank you very much indeed for your help. We've gone over now by 10 minutes, but I just want to thank you very much. I know we didn't have any other people today, but on this one, but it's a valuable session that will be recorded. I will give me my feedback as well. And in fact, I'll just you just put that slide up there. I'm not going to get my non-work phone to do it because I can't do it on my work phone, but I've
Okay, no
got I've
problem.
got this. Yeah, so much appreciated, and obviously for everybody else, this is video recorded, so we'll get the playback, and hopefully some people will play it back. So, and
Sure.
thanks very much for your time. I know it's very late in India if you're in wherever you are if you're in India today.
Yeah.
Pune, say I don't know. I'm not sure where
Pune.
you're
Yeah.
based. Pune, so it's a late
Yeah.
one for you. So much appreciated. And thank you for closing this conference. From my perspective, it's been, pretty interesting and quite useful. So much
Sure. Yeah.
appreciated.
Yeah.
And see you soon. Take
Thanks a
care.
lot, Tom.
Zan
Yeah.
Subadash.
Yeah. Bye.
Thank you for doing
Hmm.
those. Cheers.
Yeah.
Bye.
Cheers. Bye.